Maybe I need a bigger hammer. Hold on. Hi, I'm Paul Brodie. We're back in the shop. Thanks for joining us. Mitch behind the cameras. And we are having a sale on Aramaki shirts, and they've been selling well. 18% off. It is almost Christmas. It's a good time to buy. What we're working on today is EXCELSIOR handlebars. And I've got a variety of parts here that I'd like to show you. It starts with a casting, another casting. There's a lot of castings on the EXCELSIOR. So this is a sand casting. It's a tough metal, 8620. I wanted 4130, but the foundry was casting 8620. So I said, is that a good metal? And they said, oh yes. And it is, it's tough. It's a tough metal. So we have to machine this. I'm going to show you how that works. And this is a sand casting. And there's a lot of the linkage pieces that go into the casting. So these parts here of the casting, they get bored out to 1/2 inch. And that's where the linkage goes. And this is a casting. This is called an investment casting. It is 4130, and this is how it starts out. So you can see how much work goes into making it into this. That's one casting. Then there's another linkage part that goes onto the head tube. This goes on either side of the head tube. And this is what it looks like when I start out. So there's a bit of work there. And then this casting here, it starts out like that and it ends up like that. And that's the one that goes on the other side of this. You see how there's a little, like a spline, not really a spline, but it holds this because that's on a taper. And then this is 5/16 National Fine. And so that's how the linkage works, because on the handlebar, this is a handlebar. Most handlebars are 7/8 of an inch. Harley is inch, I believe, because everything's bigger on a Harley. So this is an oddball size. It's 15/16, and it's DOM tubing, which is kind of halfway between mild steel and 4130. And what goes onto this is the spiral roll. And this allows the throttle to work. It's the throttle on this side, and on the other side, it's the advance and retard mechanism. It hooks up to the magneto. So this is a really thin tube. It's chrome moly. It's 028. So that's the size that works on this, because the OD is an inch, and if you get the right wall thickness, it just goes on there, and it's a nice fit. Now these are the hand grips. I got these out of the US, and these are about $100 a pair, something like that. They're not cheap, but there's only one place that makes them. And then you can see here how it's a loose fit. So what happens is I got some aluminum tubing, and it gets pressed over this. It's basically size on size. This is an inch. This is an inch ID. It gets pressed on, and then this is too big. So after it's pressed on, this goes into the lathe, and it gets machined down to 1.080, I believe. So the wall thickness is only 40 thou. If I machine that down and tried to press that on with a 40 thou wall thickness, it would buckle or something would go wrong. So this is a heavier wall now. I press it on. I use some press lube in the arbor press, and then I machine it down, and then that's when the grip goes off. So it's quite a bit of work. And on the spiral roll, there's this piece here, and it gets machined out. This is basically laser cut, I believe. If If you look at the surface, laser cut, that all gets sanded, that gets pressed on, and then that gets silver soldered. And then on the other end is this, and it gets pressed into there, and it gets silver soldered as well. Because what happens is, on the inside, okay, bear with me. So there's an insert that goes in there, and it gets a thread, and that's where the screw goes. So the screw holds it like so, and then it doesn't fall off, and it doesn't go on too far. So there's a lot that goes on, and then there's this piece here as well, and this goes, I put this into the lathe in a holder, and then I have a bearing in the tool post, and as this spins, the bearing spins, and I hold this, and I force the bearing into that, and it rounds this to hold this. And that becomes the piece that goes, that screws into this part of the spiral roll, so that when you turn it, this gets hooked up to the linkage. There's a lot going on here. So anyway, this is Excelsior. It takes a lot of energy just to even make a handlebar. So we're going to make the handlebar. This is the casting. First thing I'm going to do is the center drill. Find the center and center drill this, and then put it in the lathe. And I believe if you look at it, it's got a little bit of a wow to it. So we're going to find out where the high spot is. Then it goes into the arbor press, and it gets made so that it doesn't have a bend in it. And then we start machining. Thanks for tuning in. I got my machinist glue, and this is used for marking out things like that. So I need to find the center. So this is basically an inch. So I'm going to set this to 1/2 inch. All right, we'll go off to the drill press now and center drill it. And then we'll go to the lathe, and we'll have it in between centers, and we'll see if it's straight or wobbly. That's about where it's hitting. You can actually hear it. And then you come over here. That's a big gap. So what I'm going to do is I'm going to press down on this surface right here. And then maybe I got to press that way a little bit. So actually, that's the high spot right there. So we're going to press down here. Okay, we're going to go to the hydraulic press. So did we get lucky or what? Okay, so that's the top. Well, actually, it's the bottom of the casting. And it's not bad. It's a lot better than it was. So that's good. We're just going to leave it like that. And our next step is in the lathe here. And each of the ends is machined down to fit the handlebar, okay? Okay, it's got a little bit of play, that's fine, because you do need room for the braids. Okay, so I've got a radius tool here. Okay, we're good. So the next step is to go to the mill. We have to face off the top. This is the top. You can see how these two holes aren't in line with the third hole. So, you know, we have to use a digital readout and offset, things like that. So let's go to the mill. Okay, so that's face now. So now we have to drill holes and bore them. Okay, so it's the boring bar next. We're going to bore these 3 holes. This is a blind hole. Maybe we'll do that one first. Okay, we're good. So now we have to do the bosses that hold on the linkage. So I'm going to leave it where it is. I'm going to take a 1/2 inch end mill and mill it. And then we flip it 90, center it up, and then we drill a hole and we ream it 1/2 inch. And then we're done. Well, we have to make sure it fits on the bike. So we're not quite done. Let's see if it fits. It's a lot of work for one handlebar. That's what I think. Let me get my hammer. It should be a little bit of a tight fit. Maybe I need a bigger hammer. Hold on. Now that is a good fit. All right, well, I'm a little tired out after all that, but thank you for watching. We appreciate it. And Mitch and I like coffees. If you buy us coffees, really helps a lot. So see you next time. Happy holidays. Take care. Here's the linkage, and this is where it goes. Goes like that. And it's a little bit of a snug fit. So it's being reamed, so it needs a little bit of a hone. I'll hone that very slightly, and that'll fit in. And that's what happens. That's how the linkage works when you are twisting the throttle or the advance and retard mechanism. And then this guy goes on the back.